Hi. So we're going to pick up where we left off. If you recall, we started with a CSV file, which we converted in Excel to a comma separated value, which is basically a text file. Each of your stations is here as a record in the table. And what we did was we used the latitude and longitude field, read it into ArcMap, made a temporary file, and then from there converted it to a more permanent file located right here in our geodatabase, January demo data. The next step, if you recall, was we took this and we defined its projection. We can right click and look at its properties and remind ourselves it's NAD83. It's basically the origin point. Then what we did is we went ahead and projected this data and saved that new data set to the same geodatabase, and here it is right below it. You can see the stark difference in how these points are projected on the surface. Let's right click on that, look at its properties. You can see that it's been projected to a North America Lambert conformal conic. So this is the projection we're going to work in. Did some research on this. Looks like this is the best to use when you're using lower 48, the Canadian provinces, and Alaska, basically all of North America. Okay, we're set. So I'm going to set up my screen to be two-panel again, just so I can click and drag information into ArcMap. It tends to be the easiest way to get started. So I'm going to grab the blue bar here of Arc Catalog, slide it against the left-hand side till I get a blue field, and I've got one panel. And remember, I can launch ArcMap right here from underneath Customize. Here's the ArcMap tool. I can launch that from right here inside of Arc Catalog. So I'll get that started. ArcMap started up, and I'm going to do the same to the other side just so I can click and drag some information in. So now I'm all set. I can now just drag this over. If you don't want to do the two-panel setup, this is too confusing, you can also, I'll right-click on this and remove it. You can also stay full screen with ArcMap if you prefer, and click on the plus sign here. This is how you can add data without clicking and dragging between the two windows. Click on the plus sign. Again, if you recall, we set up what we call folder connections in ArcMap. I can go to the drop down, click on folder connections. It shows me all the connections that I've made. Remember, this is a shortcut. We created this in our catalog. You can create them in here as well by doing the connect to folder option. So here's where our data is located. It's right in the desktop, demo data. Double click that, go into data. Again, go all the way into the cylinder looking thing. You know it doesn't look like a folder, it really is. And take the January demo data projected and click add. So there's two options for adding your data. You can click and drag, or you can click the black plus sign and use your folder connections made here to shortcut data loading. I'm going to minimize our catalog, maximize ArcMap, and we're going to run a basic analysis in this step called inverse distance weighting. This is an interpolation step. What interpolation is it's taking what is considered discrete information. These points are discrete points in space. They're separate from one another. And if I open up the table here, again, remember ArcMap has a map in the right, panel on the left where our layers can be worked with, turned on and off as needed. I can right-click at the January demo data and open its attribute table. The thing about GIS, this is the most important thing to realize, is that every one of these points is a record in the table. And I can come into the table and show you this by clicking on the point, and it highlights on the map. So every point in the table is a record. Every point on the map is a record in the table. So, and I can clear selection here. What we're going to do is take those discrete points and we're going to make a continuous surface out of them. We're going to basically take all of these points and estimate what the value is for any given information in this table. Between any two points, what is the values that lie out here in this space? I'll open the attribute table one more time, and this could be any one of these. It could be mean temperatures, mean SPD, mean WCT, etc. So we can choose any one of those temperature or temperature-derived piece of information to make a continuous surface. Okay, how do we do that? So, come back up here to the search. Again, right underneath Windows, there's a search option. It's going to open the search window. Come over to the search window. I'm going to click on Tools again, because remember there's a lot of tools in here. And I want to make sure I can just zero in on what I need without clicking through a lot. And I'm going to type the letters IDW for inverse distance weighting. This is pretty standard for doing meteorological data. You can see there's three options here. There's three different extensions to this software that use IDW. There's 3D Analyst, it's pretty self-describing if you're going to work with the data, and a third element in dimension in elevation. You're probably going to want to use 3D Analyst. Geostatistical Analyst if you've got really large data sets. This is a big data extension that will allow you to kind of process through those. Spatial Analyst is just working with it in 2 dimensions, and that's what we're going to work with here. One thing I want to point out to you is if you're going to use an extension to this software, any one of these 3, you're going to want to make sure that extension is turned on. By default, they may not be turned on. Come over to the Customize window, menu, and go down to Extensions. You'll see a list of all the extensions that the software has. Spatial Analyst is checked in this case. I'm going to turn it off and show you what happens. I'm going to turn off Spatial Analyst, click Close. Now if I come over here and choose the Spatial Analyst IDW, I'm going to get an error message telling me I'm not licensed to do this. Click OK and OK. So if you ever get that error, all you need to do is come over to Customize, Extensions, and choose the extension you want to use, in this case Spatial Analyst, and close. So now I can run the Spatial Analyst tool. Opens right up. I'm going to walk right down and use these. Fill out as much information as you needed. You want to do at least the green dots. Those are required. And I'll talk through a couple of these other ones. One thing to know about all the tools in the software, there's generally a help that will pop out to the side and will change as you click through each one of these fields. And it gives you a description and what you possibly need to put in there to be successful. First one is the input features. Again, you can use the drop down or click and drag, however you want to do it. Then there's a Z field. By default, it's going to scan the table and find the first integer field, in this case latitude. We don't want to do latitude. We're going to click the drop down and we're going to find one of these other variables, one of these other attribute fields we'd like to analyze and create a continuous surface of. This case is going to be mean WCT. Okay, now we're going to write our output to the proper location. By default, there's a default geodatabase that this will get written to. Sometimes people forget to change their output location, hit OK. That's okay. The default geodatabase is usually in your M drive. So click the folder at the bottom, at the end of the field, and again go to your folder connections. Show you we're in our folder connections. We created our catalog again. Double click on demo data and data, and then go right into the geodatabase again. And we're going to save this as January WCT data. Notice this says raster dataset. A raster is a continuous surface of information arranged in grids. Every grid cell will have a value, and there's no longer going to be a discrete point in space with one record and one dot. It's going to be a continuous surface, and you'll see what I mean in a second. Click Save. Output cell size. This might be something you want to consider exploring options for changing and experimenting with. You can see that it's got a default way of actually calculating that. I won't go into much beyond highlighting this for you, but you can change your output cell size. Usually this is limited to if you've got another raster data set you're going to put over top of this, and that cell size has got a defined width and height to it, width and length. You probably have to stick with that. It's your limiting factor. In this case, we don't really have one, so you may want to experiment with different sizes there. Power optional. This is all optional. You don't have to change these. This is describing how much effect each one of these surrounding points has on its neighbor. You can read that there. Variable search, you could do a fixed search or a variable search around each point. By default, it is variable. You can read more here in the help about that as you walk through this. Number of points, this is the neighborhood. How many points do you want to have affect? How many neighboring points do you want to have an effect on the calculation between any 2 points? Again, these are all things you can work through. Polyline feature, this allows you to set up a fence and cut it off at the end of the United States continent. We don't have that in there yet, so we're not going to do that, but you can do that. And I'm going to go ahead, now we've got this all set up, I'm going to go ahead and click OK and run the tool, and you'll see the result. Okay, so now you can see the result. I'll right click on this and zoom to layer. Get it all on the screen there. You can see now we've created a continuous surface between each of these. So each band now, each color band is now a classified temperature value based on the values derived from the points. I can right click, there's no attribute table here now. We can work with that and work with those different things and create one. But for now, it's just each one of these cells in the in the raster surface has a value. If I click on the Identify tool, I can click on any one of these points and get its returned pixel value. That's it for now, and then what I'll do in the next video is we'll talk about creating contours and clipping this out to kind of shape it to the continental United States and North America.